Hi children, today in this class let us see chapter 6, Squares and Square Roots. What is the square of any number? Square of any number, suppose let us take 5. Square of 5 is denoted as 5 square like this, and this is defined as 5 times 5, which is equal to 25. Similarly, 6 square is nothing but 6 times 6, which is equal to 36. In general, if we take a square is nothing but a times a. So, square of any number is the number multiplied by itself. Now, if you take the squares of natural numbers, 1 square equal to 1 into 1, which is equal to 1. 2 square equal to 2 into 2, which is equal to 4. 3 square equal to 3 into 3, which is equal to 9. 4 square equal to 4 into 4, which is equal to 16. Similarly, 5 square equal to 25. 6 square equal to 36. 7 square equal to 49. 8 square equal to 64. And 9 square equal to 81. 10 square equal to 100. If you go further, 11 square equal to 121. 12 square equal to 144. 13 square equal to 169. 14 square equal to 196. 15 square equal to 225. All these numbers 1, 4, 9, 16, 25, 36, 49, 64 and here 81 to 225, and we go on further also. All these numbers are squares of some natural numbers. All these numbers are squares of some natural numbers. These are called square numbers or perfect squares. 1, 4, 9, 16 and so on. These numbers are called square numbers or perfect squares. Now if we observe the units digit in the square numbers, what are the units digits you write? So here we have 1, this is 4, this is 9, this is 6. The digit in units place I am writing. Here is 5, here is 6, here is 9, here is 4 and here is 1, 0, 1, 4, like this we have 9, 6, 5. Now if you observe, what are the digits we have in the units place? 0 is there, 1 is there, then 4 is there, 5 is there, 6 and 9. These are the only digits we have in the units place of a square number. What are the other digits we have? 2, 3, 7, 8. If there is any number with these digits in their units place, those numbers are not perfect squares. But be sure, if you have any number in its units place 0, 1, 4, 5, 6, 9, it doesn't mean that it is exactly a perfect square. But be sure, a perfect square has the digit in units place as 0 or 1 or 4 or 5 or 6 or 9. But any number which has these digits in their units place, it doesn't mean that those are perfect square numbers. Be sure. So a perfect square number don't have their units digit as 2, 3 or 7 or 8. Now if we take a number, now let us take a number which has 5 in its units place. Suppose if we take 15 square, this is equal to 225. Now if you take 25 square, that will be 625. 35 square if we take, that is equal to 1225. So here if you observe the pattern here, 5 square means we can take that one as 25. Now from this 3 we can get this 12. How? So take 3 and multiply with the next natural number, that is 4. So 3 times 4 is 12. Similarly, we can say, suppose if we take 45 square, this is equal to, first write 25 for this 5 square, then you take 4 and the next number is 5. So 4 times 5 is 20, write 20 here. Similarly, if you take 75 square, this will be equal to 5 square. So write 25 here. Then 7 times 8, which is equal to 56. You write 56 here. By using this pattern, we can find out square of a number which has 5 in its units place easily. Now let us see some interesting patterns in square numbers. Adding triangular numbers. First of all, what is a triangular number? Let me take one pattern. Suppose there is one dot here and 2 dots and one more dot like this, and here 1, 2, 3 dots, and here 2 dots, and here 1 dot. Let me take 4 dots now. 1, 2, 3, 4. Here 1, 2, 3. So in the next row we have just 2. In the next row we have 1. So here how many dots we have in the first one? 1. Here we have 3. Here 3, 4, 5, 6. Here we have 10. Now if you observe these dots, so you see this is like a triangle. This is also just like a triangle. This is also just like a triangle. So these numbers are called triangular numbers. So 1, 3, 6, 10. 1, 3, 6, 10. Next one is 15. Next one is 21. These numbers are called triangular numbers. Now in these triangular numbers, if you take 2 consecutive triangular numbers, so that means suppose if you take 1 and 3. So 1 plus 3 let us take, that is equal to 4. That is nothing but 2 square. Now if we take 3 and 6, 3 plus 6 which is equal to 9, and that is equal to 3 square. Similarly, if we take 6 and 10, so take any 2 consecutive triangular numbers. 6 plus 10 which is equal to 16, we can write this one as 4 square. So from this we can say that sum of any 2 consecutive triangular numbers is a perfect square. Now let us go to one more pattern. Numbers between square numbers. Suppose if I take 2 square, that is equal to 4, and let me take 3 square, that is equal to 9. Now in between this 4 and 9, that means in between 2 square and 3 square, how many numbers are there? What are the numbers we have? So in between 4 and 9 we have 5, 6, 7, 8. Except this 4 and 9, we have how many numbers? 4 numbers. Now observe the original numbers, that means 3 square and 4 and 2 square. If you take 3 square minus 2 square equal to, that is nothing but 9 minus 4, which is equal to 5. Now this 4 is 1 less than this 5, you see. So we can say this is equal to 4 equal to this 5 minus 1. So that means in between any 2 successive square numbers, how many numbers we have? If we want to find out, just take the difference of those 2 perfect square numbers and take 1 less than that number. Let us see one more example. Suppose if I take 3 square and 4 square. So 3 square is 9, 4 square is 16. In between 9 and 16, what are the numbers we have? 10, 11, 12, 13, 14 and 15. So how many we have here? There are 6. Now if you observe 16 minus 9, the difference of 4 square and 3 square, that will be equal to 7. Now this 6 is 1 less than this 7. Similarly, if we want to find out how many numbers are there in between, suppose 6 square and 7 square. This is very simple. 6 square is 36 7 square is 49. So 49 minus 36, that is equal to 13. So you take 1 less than this one. That is 13 minus 1, which is equal to 12. We have 12 numbers between 6 square and 7 square. And these 12 numbers are non-perfect square numbers. That means these are not perfect square numbers. Now let us go to one more pattern. Adding odd numbers. First of all, what are odd numbers? When a natural number is divided by 2, if it gets 1 as the remainder, then that is said to be odd number. So, if we divide a number with 2, then you have to get the remainder equal to 1. Then that is said to be odd number. What are the odd numbers we have? 1, 3, 5, 7, 9, 11 and so on. These are the odd numbers. Now if we add these odd numbers, so like this you see 1 plus 3. 1 plus 3 equal to how much? 4. Now 1 plus 3 plus 5 equal to how much? That is equal to 9. 1 plus 3 plus 5 plus 7, which is equal to 16. 1 plus 3 plus 5 plus 7 plus 9 if we take, that will be 25. Now have you observed anything? So 4 equal to, you see this is 2 square, 9 equal to 3 square, 16 equal to 4 square, 25 equal to 5 square. Like this, there is some pattern. Now suppose if you take the last one, how we got 5 square? Is there any relation between these numbers and this 5? That is very simple. You see how many numbers are being added. So this is 1. So 1, 2, 3, 4, 5. So we are adding 5 consecutive odd numbers starting from 1. So that will be equal to 5 square. So from this we can say that suppose we have 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17. This is equal to, you need not to add all these numbers. Just count how many numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is equal to 9 square, which is equal to 81. So let us go to the next one. Sum of consecutive natural numbers. Suppose let us take 3 square. 3 square equal to how much? 9. We can write this one as 4 plus 5. Now you can write this 4 as 8 by 2 and this 5 as 10 by 2. Now we can write 8 by 2 as 9 minus 1 by 2 and 10 as 9 plus 1 all over by 2. Now this 9 can be written as 3 square. So 3 square minus 1 all over 2. This is 3 square plus 1 all over 2. Now you observe here, this 3 square can be written as sum of two consecutive numbers. And those consecutive numbers are in some pattern. Let us take one more example. Suppose let us take 5 square. 5 square equal to 25. So we can write this as 12 plus 13. Now this can be written as 24 by 2 and this is 26 by 2. 13 as 26 by 2. Now 24 by 2 can be written as 25 minus 1 all over 2 and 26 can be written as 25 plus 1 all over 2. So this is 5 square minus 1 all over 2. This is 5 square plus 1 all over 2. So we can observe some pattern is there. Now if we take 7 square, so that will be equal to 7 square minus 1 by 2 plus 7 square plus 1 by 2. You can write like this. So this is equal to 7 square means 49. 49 minus 1 all over 2 plus this is 49 plus 1 all over 2. So this is equal to 49 minus 1 means 48. So 48 by 2 plus this is 50 by 2. So this is equal to 24 plus 25. So these are the two consecutive numbers which can be written as 7 square. So 7 square can be written as 24 plus 25. Suppose let us take one more example. Suppose we need 11 square. 11 square equal to, suppose we want to write 11 square as the sum of two consecutive natural numbers. We can easily write as 11 square minus 1 all over 2 plus 11 square plus 1 all over 2. So this is equal to 11 square means 121. So 121 minus 1 all over 2 plus this is 121 plus 1 all over 2. So this is equal to 120 by 2 plus 122 by 2. 120 by 2 means 60 plus this is 61. 122 by 2 means 61. So these two are the two consecutive numbers which can be 11 square written as. Let us go to the next one. Product of two consecutive odd or even natural numbers. Suppose if I take two consecutive odd numbers. Let me take 7 times 9. 7 times 9, we know that 7 into 9 is 63. This can be written as 64 minus 1. This is equal to 64 is nothing but 8 square. So 8 square minus 1. So 7 into 9 can be written as 8 square minus 1. Let us take one more example. Suppose if I take 11 times 13. 11 times 13 is 143. This can be written as 144 minus 1. 144 is square of what? That is square of 12. So 12 square minus 1. If we observe these two, we can observe one thing. Here we have 7 times 9. Here we have 8 square minus 1. That means 7 times 9 is nothing but 8 square minus 1. That means how this 8 comes? This 8 is the middle number of this 7 and 9. Similarly here also this 12 is nothing but middle number of this 11 and 13. So in the same way, if we want to find out suppose 15 times 17, we can usually calculate this by writing the middle number is 16. So 16 square minus 1. 16 square is 256 minus 1, which is equal to 255. So 15 times 17 is 255. Here we took odd numbers. Now let us take even numbers. Suppose let us take two consecutive even natural numbers. Suppose 4 into 6. 4 into 6 equal to 24. This can be written as 25 minus 1, which is equal to 5 square minus 1. Now you observe this 5 is in between 4 and 6. Now let us take 8 into 10. Which is equal to 80, and this can be written as 81 minus 1, which is equal to 9 square minus 1. Now this 9 is in between 8 and 10. So whether those are consecutive odd numbers or consecutive even numbers, it doesn't matter. In both the cases it works. Now how it works, let us see. Remember, a plus b times a minus b is equal to a square minus b square. You remember this one. Now if you take instead of b, if you take 1, then a plus 1 times a minus 1, this is equal to a square minus 1 square, which is equal to a square minus 1. Now if we take a as one natural number, before that we have a minus 1. And after that we have a plus 1. So these are the, suppose these three are the consecutive natural numbers. Now a minus 1 times a plus 1 if you take, that is equal to, as we have seen earlier, that is equal to a square minus 1. So that means a is nothing but the middle number. So like that it works. Let us go to the next one. Some more interesting patterns. You see, except 1, all the square numbers are either multiples of 4 or one more than multiple of 4. All the square numbers, let us take any square number. Suppose if we take 2 square, which is equal to 4, and this is multiple of 4. Okay, let us take next number 3 square. 3 square is nothing but 9. we can write this one as 8 plus 1. Now this 8 is multiple of 4. So plus 1. That means this is 1 more than multiple of 4. Now if you take 4 square, that is equal to 16. This is multiple of 4. Now if we take 5 square, that is equal to 25. We can write this one as 24 plus 1. Now this 24 is multiple of 4. So that means this number 5 square is 1 more than the multiple of 4. So in general, if we continue like this, we can say in general, except 1, all the square numbers are either multiples of 4 or 1 more than the multiple of 4. This is one interesting pattern. We can take one more interesting pattern. We know that 1 square equal to 1, 11 square equal to 121, 111 square equal to 12,321. In the same pattern, if you write 1111 square, we can write this is equal to 1, 2, 3, 4 and then 3, 2, 1. Suppose if you want to find out 1111, that means here how many? We have 4 ones. Here we have 4 ones. So write 4 here, and before that you write 1, 2, 3, and after that you write 3, 2, 1. That's it. In the same way, if you want to find out the value of like this, how many ones are there? 5. So this is equal to write 5 here. Before 4, 3, 2, 1. After that also 4, 3, 2, 1. Similarly, if you observe one more pattern, 7 square equal to, we know that 49. Now suppose 67 square, that is equal to nothing but 489. Now if you take 667 square, this will be equal to, simply write 4 here and 9 here. In between you write 1 4 and 1 8. That's it. Suppose if you want to find out 6,667 square, write 4 and 9. In between write 2 4s and 2 8s. That's it. That means 4,44,889. That is the square of 6,667 square. In the same way, if you want to find out 66,667 square, that will be write 4 here, 9 here, and write 3 4s here and 3 8s here. That's it. Like that, we can find out so many interesting patterns in numbers. That is the beauty of mathematics. Hope you enjoyed the class. If you enjoyed the class, please subscribe my channel.